You can eat the salad, skip the dessert, keep your numbers looking fine, and still walk into a 2 p.m. investor call with slower thinking, feeling like your brain is moving through wet concrete. Your glucose can stay healthy on paper, while your cognitive performance slowly crashes in real life, not because the number is dangerously high, because the system stays disrupted longer than it should. That's the hidden story behind many CGM curves. If you are paid for clarity, judgment, and fast thinking under pressure, this is not a wellness conversation. It's a power conversation. By the end, you'll understand something most people never notice. Two people can eat the same meal, have equally healthy glucose averages, and still walk into radically different afternoons. One feels clear and productive. The other feels foggy, irritable, and drained. Same inputs, different system. This story starts far from modern wearables. In 1921, Frederick Banting, a young surgeon, was about to change medicine. He was searching for a way to cure diabetes. Severe diabetes at that time was often a death sentence. Doctors could starve patients to slow the end. That bought time. It did not save them. Banting thought the pancreas held the key. Working in the heat of a crowded University of Toronto lab, he extracted pancreatic material and tested it on diabetic dogs. Many attempts failed. Some extracts were dangerous. Then one refined extract changed everything. Blood sugar fell. The dog improved. They'd found the invisible signal, insulin. Later, insulin became a human treatment. Insulin moves glucose out of the blood and into tissue. Without it, blood sugar rises while the body starves. That breakthrough shaped medicine for a century. Glucose became a tank level. Too high is bad. Lower it. That made sense for survival. But now watch this. A century later, we're not just looking at uncontrolled diabetes. We're looking at people with normal labs. People who exercise, lead companies, and look metabolically fine. The question has changed. It's no longer just, can the body lower glucose? It's, how smoothly can the body control glucose under pressure? In 2026, Communications Medicine analyzed CGM data from 8,025 adults without diagnosed diabetes. Not a clinical extreme, average adults. You'd expect dozens of metrics, but the result was astonishing. 3 glucose metrics explained more than 80% of the differences between people. 3. Mean, variance, and autocorrelation. In plain language, where your glucose tends to sit, how much it swings, and how much the past keeps affecting the present. That third one matters, autocorrelation. It means your current glucose is still linked to where it was before. The system has memory. It doesn't reset cleanly. The meal is over, but the biology is still dealing with it. Think of your glucose response like a high-performance car's handling. Mean glucose is cruising speed. Variance is how violently the car swerves. Autocorrelation is whether the steering wheel keeps pulling after the turn. A resilient system takes a meal, responds, and returns toward baseline cleanly. Glucose is supposed to rise after food. That's normal. The problem is when the rise becomes sticky. Sticky means the prior spike keeps influencing the next CGM reading. The system hasn't fully recovered before the next demand. Breakfast bleeds into lunch. Lunch bleeds into the afternoon. And your meeting inherits the nervous system your food created. Vitas tied in YNG Setayasoid Senbrain Sagittarius. The 2026 study showed these 3 metrics are not just statistical models. They are early warning signs of atherosclerosis and to unhealthy changes in the liver, including fat buildup and stiffness. Let that land. The CGM wasn't just showing a food reaction, it was revealing a metabolic phenotype, a mysterious operating pattern. If you want more breakdowns like this, taking performance biology out of hype and into mechanism, subscribe to Biology of Power. The goal is to understand biological systems that make high performance possible. Let's decode this pattern. The autocorrelation metric, SCR in den Torpshinsanikor, is summated Marides, Y andasan varsin ton, endocrinekrudson, endotenantinaridian noir, is especially important. It signals that the body is becoming worse at handling blood sugar. The study linked it to lower insulin sensitivity, weaker insulin response, and poorer insulin processing. Translation, your cells may respond less efficiently to insulin. Your pancreas may react more slowly. Insulin may linger longer, so the curve stays disturbed. Not because one meal was morally bad, but because the control system is sluggish. A healthy system absorbs stress and restores order. A vulnerable system absorbs stress and keeps echoing. Now here's where this becomes a real-life problem. Your career is not measured by average lab numbers. It's measured by whether your brain works at the exact moment it needs to. Can you think clearly after lunch? Can you stay emotionally regulated at 4 p.m? Can you notice weak signals when everyone else reacts? There's growing evidence that unstable blood sugar affects the brain, especially when glucose swings are large. A 2024 study tracked people with type 1 diabetes using CGMs and smartphone brain tests in daily life. People with larger glucose swings showed slower thinking and lower mental accuracy. Be precise, that study was in type 1 diabetes. It doesn't prove every brain fog episode is caused by glucose, but it does support the idea that unstable glucose can impair thinking. And in high-pressure work, even small drops in clarity matter. A delayed reaction, a worse negotiation, a sharper-than-needed email. Your average glucose won't tell you that, but the curve might. Here's the truth. A CGM is not a glucose scoreboard. It's a metabolic resilience test. It's like your average is the alibi, and your variability, the crime scene. Now let's make this usable. Don't use a CGM to punish yourself after meals. Use it like an investigator. Run a 10 to 14 day experiment. You're not trying to be perfect. You're trying to reveal your pattern. First, baseline. What happens overnight? Morning glucose is influenced by hormones, sleep quality, stress, late eating, and alcohol. Don't treat one morning as truth. Look for repetition. Second, meal response, not just the peak. Ask 3 questions. How high did it go? How fast did it rise? And how long until it came back down? Most people skip the third. Peak and return tells a different story than peak and stay. Third, compare inputs. Take a real meal you actually eat. Run it twice. Once after good sleep, once after a short night. Same food, different nervous system. Watch what changes. Many people think the meal is the variable, but often it's readiness, sleep debt, stress, or alcohol. Any of these can make a familiar meal look unfamiliar to your metabolism. Fourth, test levers. Protein and fiber before refined carbs soften the rise. Adding fat slows absorption, but may prolong the curve in some people. A 10-20 minute walk or a couple of squats after eating. Improves glucose disposal. Contracting muscle pulls glucose from blood more effectively. Fifth, watch for persistence. If breakfast causes a large peak, lunch overreacts, and your afternoon still drags, you're seeing the memory problem. That's autocorrelation in real life. The past is still metabolically present. Your body hasn't finished its cycle. Just think. Mean, variance, and persistence capture most meaningful differences between people. Those features map to vascular and liver risk, even before diabetes shows up. That's the hidden phenotype. Not necessarily disease, but vulnerability. And vulnerability under pressure becomes performance loss. Return to Banting. In 1921, the miracle was finding the hormone that could bring glucose down and keep people alive. Banting showed insulin opens the door. A CGM shows how well the whole building handles traffic. Do people move through smoothly? Do hallways jam? Does the system clear? Or does every meal leave a backlog? Insulin explained why glucose stability matters. A CGM reveals whether your stability is real. Why can 2 people eat the exact same lunch, have the same normal average glucose, and only one crashes at 2 p.m? Because averages hide the story. They flatten spikes, recovery, and instability into one clean number. One person rises slightly, then returns to baseline fast. The other spikes harder, stays elevated longer, and carries that metabolic stress into the next meeting, decision, or task. Same average, completely different biology. Here's the shift most people miss. A normal average glucose level does not automatically mean your metabolism is stable, and that changes the real question. Not, what food is bad? But, what conditions make my system unstable? Because that question gives you leverage. You stop obsessing over single glucose readings and start recognizing the patterns that quietly reduce your energy, clarity, and performance. It's about understanding your biology. Obsession asks, how do I make the graph look perfect? Understanding asks, what is this graph teaching me about how my body responds? One important note. CGMs do not measure blood glucose directly. They measure glucose in surrounding tissue, which can lag behind. The sensors are useful, but not perfect. And if you have diabetes, PRE diabetes, a history of eating disorders, or take glucose-related medication, this should be done with medical guidance, not as a DIY experiment. But for many high performers, a short CGM experiment reveals something standard lab tests cannot. Not just what your glucose level is, but how your system behaves under real-life conditions. And performance is built on behavior. Pay attention to how fast you recover. Don't ask, is my glucose good or bad? Ask, How adaptable is my system? The healthiest systems are not the ones that never change. They are the ones that can respond to stress and return to balance quickly. That's true in metabolism, it's true in leadership, and it's true under pressure. Power is not the absence of stress. Power is the ability to recover fast and precisely. A deeper question remains. If the same meal produces a different glucose curve depending on sleep, stress, exercise, and timing, then your metabolism is not responding only to food, it's responding to your entire lifestyle. And that changes the game. The next frontier is not just nutrition, it's biological readiness. Once you see that, a CGM stops being just a food tracker. It becomes a mirror, because it reflects what your sleep, stress, schedule, and daily decisions are doing inside your body. Anxiety. Often long before symptoms or diagnoses appear. So next time you look at a glucose curve, don't just ask how high the spike was, ask what it cost you afterward. Your focus, your energy, your clarity, that's the real metric. And this raises a much bigger question. If glucose variability can quietly affect energy, cognition, and recovery, what other normal biomarkers are hiding performance problems in plain sight?